Hello, Amalia. This is our second partial project explanation. We are Victor, Andrik, Omar, and Pacheco.
Okay, so the most important part of doing a project or even researching anything that's valuable, uh, everybody has to do his or her own individual research. What does this mean? Everybody has to look up for different definitions. So then we can all get together one definition and understand the project better.
That is correct. Now Pacheco will explain
Well,
what
I will
is.
explain the normal distribution.
Yes.
Okay, the normal distribution is a kind of a function that represents all the data from the random discrete variable, and is represented in a bell-shaped diagram in a graph. Also, it is named with the Gauss distribution. Okay, all of this data is concentrated in the peak of the bell, in other words, in the center. The further data is from the curve, also referred to the middle. The least likely is the probability of it to happen in the given. An example is at a stock returns, test of results, and if the standard errors are continuous random variables. Okay, now I will explain the characteristic of the normal distribution. They are principal four aspects of the normal distribution. The first is the symmetric. This characteristic is located on both sides. They are both equal and therefore they must be perfect symmetrical in a cube. The second characteristic is the unimodal. It is a body that has a unique mode and only one peak. And the third is the asymptomatic. There is an element that is close for the x-axis and is located near to the ends of the graph, but must be touched. And lastly, the fourth characteristic of the normal distribution is the mean and, and mode and median, which are all equal.
So we can have a better thought of this. We can just look at this cost diagram, and there we can follow up with what Juan Pacheco just said. So now it's my turn to explain the standard normal distribution. It is known as a special method using a very special case of normal distribution. It happens when the standard deviation of any random variable is 1 and the mean is 0. This sometimes is called the standard score also. It is expressed in the next formula, which is z equals x minus mu, all divided in the sigma. And yeah, that converts the variable x into a z variable. This is also called a standardized variable. And here is the normal standard distribution table, which we have also used, and where we also look at something that some people in MIC have also learned with. So this is an a alpha error, and on the left side there's liberty. There's a grade of liberty.
Now Andrik will explain these exercises we made with the z-score table.
Hello, my name is Hendrik, and first of all, the C value is used to know the probability of the area that is to the left of the Gauss distribution table. The Gauss distribution table is this one, and the Z number will give you the area that is on the left side, which would be this. And this is just the calculations of P, Z is less than minus 1, and you just look for the Z table of, for the Z value of minus 1 in the table, and that is the answer. And it works for all of the values that are less than. And if you're looking for a value that is greater than minus 1.5, the only thing that you have to do is to subtract 1 to the number that you find in the z table, because the z table gives you the value to the left and you're looking the value to the right. Therefore, you just take one out of whatever number you have in the z table. Going down to the other problems that are probabilities between two numbers, the only thing that must be done is to take both values, or for example this one, take both z values that are seen here, and you just subtract them, making the greater subtraction would be 1.1 z to see the z value of 1.1 minus the z value of minus 1.1, and this gives you the area in between these two areas, which would be in this case 0.23808. Thank you for watching. And
no, wait.
oh.
Yes, where P is probability and the scores are calculated. The first decimal, you choose it from this column, and the second from this. And we had other problems where we had to investigate how to do these exercises with larger numbers. So for instance, let's take the first example. The mean was 505, and the standard the sigma was 15, and we had to investigate how to do these problems. We had a bit of trouble because we did a new house, so the first thing we investigated was something complicated, and which was the PDF general formula, which is this image. And since it's a complicated equation, we used Wolfram alpha to calculate it. But then we realized that it could be done with the formula that is used for the standard normal deviation, where you subtract 2x the mean and you divide it by the standard deviation. And in this case, it was just you can see here x minus mu over sigma 500 minus 505 over 15, and you got the exact variable that was calculated in the calculator. So both techniques were correct. Yes. And thank you for your attention. And
thank you.
That's it.
And yes, we had a lot of fun doing this.
Bye.